So today we're going to talk about no halls, algorithmic phasing, or wake and wiggle. And so after power up or reset and after enable, this is the status indicator indicating that the drive is disabled. So after enable, it's going to power up and it's going to wiggle the motor shaft a little bit. Now you can see I'm wiggling it here, but the algorithmic phasing will wiggle it even less. So we'll start off by looking at the parameter dictionary, and that'll show us about this parameter B2, which is for commutation mode. And normally, if you have halls and incremental encoder, this is set to 0, so it just automatically phases using the halls. But there's this bit 5, if it's set, it's algorithmic phase. And so that's the wake and wiggle, no halls. And it says we should read the CME User guide for more information. So I like this parameter here because when you write to it, the value of 5, again, it'll put it in this mode. If I was phased and I want to try to phase again, let's say my phasing fails for some reason, I set this parameter again, and I have to go through this procedure of enabling the drive to get it to phase. But let's take a look at the CME User guide first. There's a section on manual phasing, so this helps us figure out how to phase with halls. And there's some, manual phase screen, and you can see the hall indicators and the encoder counts, and you can see the current. When we do no halls, right, this procedure says, we skip to the phase initialization for motor without halls. And so this is the no halls algorithmic phasing. Copley strongly recommends the use of halls for commutation. And you could also use an absolute encoder, to figure out where you are within the electrical cycle. But that's a pretty stern warning about it's okay to use no halls. Just make sure you know what you're doing and make sure, the cable grounding shielding's good. And, Copley's the best in the world at this, so it's not going to be a problem. Just make sure it's okay. I mean, you can't wake and wiggle with the brake on. It won't move. You can't have gravity make something drop to the bottom. It'll flop like a fish when it gets to the bottom. So just, approach this with caution. Now it says less than a third of electrical cycle. I was down around 1/10 of one electrical cycle, so hardly perceptible motion. But this talks about the procedure for initializing on the manual phase screen. You can test it out. By default, we would start off with 400 milliseconds that's used in the algorithm. And you can see there's a current we use. Maybe the default's peak current. I like the continuous current. I mean, if a motor's not going to move when you apply the continuous current, then you have to apply more than the continuous current. And so continuous current may be a good place to start off. But so this manual describes each of these options that we're using. There's a new option that I'll show you, but the time, it's used in the algorithm to ramp up the current, make sure things steady state. The current is what we ramp to, so the phase init time, phase init current. Forced phasing applies current across a pair of wires. 90-degree increments, if you start off in one direction and it keeps hitting the hard stop, well, if you do 90-degree increments, eventually you won't hit the hard stop. And then, of course, you can have an offset like plus or minus so many degrees from its normal startup position. So let's take a look at CME and see how we can use this algorithmic phasing. And we'll learn about what it does. So on the basic setup screen or the setup screen, we're going to say there's no halls. It's not a good idea not to have halls, but sometimes they don't fit or you can't get an absolute encoder. And in that case, you got to make sure your cabling grounding shielding is good. You don't want any count drift. So that'll mess up your phase because we don't know where we are if the encoder is not telling us where we are. So in this mode of operation, you can see here on the control panel that the motor is not phased. Okay, so it's disabled and it's waiting to be enabled. I can try to enable it here with the enable button. All I've done is change the mode from disabled to enabled mode, but I'm still disabled because I'm using an input. Input 1 is configured as active low, hardware enabled. So I will have to enable the drive before it tries to phase. We're going to check this this B2 parameter, get B2, and I see the value of 5. So if I want to run the phase init again, I'll have to set that value again. So let's take a look at this, and we'll trace it on the scope at the same time. So I got record. I'm going to look at the actual position over time, the current over time, the motor phase angle, which is going to be acquired, the fact that it's been phase initialized, and I'm going to trigger on input 1, which is my hardware enable. And so what we'll see is the drive will become enabled and the motor will wiggle. So let's pay close attention to the wiggling of the motor and see if we detect any wiggle there. So it's trying to phase. You see that? Hardly saw anything. But now we're phased and everything's good. So we'll take a look at what happened over time. So I ran a scope trace for 2.5 seconds because the algorithm is done in multiples of 400 milliseconds. So after I enable, active low enable, we'll apply a small amount of, or no current. So this is 0 current. And we'll look at the motor position and we'll see the phase. And then we'll ramp the current up over a period of 400 milliseconds up to the current value of 2 amps, which I'll show you the screen for setting that in a minute. And so we see the motor moves or doesn't move very much at all, so only a little bit of actual motor position. And then we apply current again, no current, and then ramp the current up. Now this time we're applying current to a different phase, and the motor pulls. So we've gone from not moving to a little bit of motion, and then we hold it again for another 400 milliseconds to make sure it goes to steady state. And you'll see what I mean when I zoom in here. When you start applying current, it's going to move, and there may be some time constant associated with like a little motion bounce. So you got to wait for that to steady state. So this time is reused in the algorithm. And then it applies the current and it confirms the phasing. And you see here, the last current goes back to 0, the motor moves and pulls, and the phase becomes initialized. So that's a successful run of the algorithmic phasing. So now you can jog the motor, and you're all phased. And again, just be very careful of what happens when you lose your encoder, right? You disconnect the encoder, you get false counts, you get count drifts, you can monitor the position here, and you'll see, your phase will start to leak. Your current will go way up. Again, if I want to redo the phase initialization, so I'll clear that and hit record again. We're gonna send this write 5 again to that parameter, and you'll see right now the motor phase is okay. Doesn't know otherwise. So when I set this B2 commutation mode parameter again to the same value, it reinitializes the need to do phase init again. So motor is not phased yet. So on enable, we're going to do the wiggle, and I'm going to enable it. I heard the current going to the motor, but I hardly saw any motion on. That's like 50 counts out of 8,000 on this motor, which is it's an 8-pole motor with 4 electrical cycles, so that's less than 1/3 of an electrical cycle. So there it is. It just ran the algorithm again, and the motor is phased successfully. There is on the manual phasing screen, we can see there's some configuration of the phasing. So there's some knobs and buttons by which we can use to adjust things. So you can go forward or reverse and apply a certain, some current. You want to make sure the motor is moving when you're applying the phase init current. So we'll take a look at this. Let's just do a nice, healthy, continuous current. I rotate the current vector through 1 electrical cycle, and the motor moves a little bit. This is an 8-pole motor, so it's got 4 electrical cycles. But you'll see here, everybody gets a chance to apply plus or minus 2 amps. And then when I go forward, I got counts going up. And so the phase, do I invert the motor wires to make forward be the other direction? Do I invert the feedback to make sure counts come up? And then you can see the parameters defaults 400 milliseconds. And actually, the default on this from the calculated values was 4 amps because that's my peak current. So I dialed it down. As long as 1 amp is still sufficient for wiggling the motor a little bit. If you have so much friction the motor can't wiggle, you need more current. I'm going to use the motor's full continuous current. But you see there's options like, well, what happens when I hit a limit switch? So we have an option for limit switch, and this increment by 90 degrees will continue to run the algorithm through all 360 degrees. If I tried this way and hit a hard stop, or I went that way and hit a hard stop, eventually it'll work. Or you could just add an offset to it. But I think this increment by 90 degrees may take a little longer, but it gives you more of a guarantee that it will phase initialize on power up or reset. Again, if you get count drifts when your drive's enabled, so look at this number here, right? My motor shaft is not moving, and so I better not get counts. So if I'm sitting there and my counts are slowly drifting up and I'm not moving, well, then I have bad cabling, grounding, shielding. So I think that's it for today. Thanks for watching.